you have a portfolio with a very high number of assets in it. For simplicity, I will assume equal weighted, even if there are market weighted. The argument doesn't change. Math involved is a little bit more involved, but the nature of the math doesn't change. And let's call this portfolio portfolio's return. Come on, R0T. Okay, then return on that portfolio is going to be the average of return of the individual portfolios, right? J. And I'm gonna write this and you can write this as three separate averages. The alpha J are constant numbers that, in a sense, uh, expected return if there is no effect from systematic risk and unsystematic stuff. So I'm going to call that alpha bar, right? If you look at the, what happened there? If you look at the second summation, the term MT does not depend on J. So it could come out of summation sign. So that will be beta bar times MT. So this average portfolio or equal weighted large portfolio is also subject to systematic risk. As we would expect, if a risk affects everybody, obviously the average is going to be affected too. Plus average of the UJs. So I'm going to call that U bar T. Okay. Now, there's one thing we know from one of the three fundamental laws of statistics, which are law of large numbers, central limit theorem. You may have heard those. The third one, I am almost sure you haven't heard. It is called the law of iterated logarithms. It has to do with the asymptotic theory of approximations. When you're trying to figure out the approximate distribution of complicated stuff, it comes in handy. But the law of large number is the most important one. Law of large numbers says the following. And I'm going to state it loosely, not in a very mathematical way. Average of a large number of uncorrelated or lowly correlated random numbers with expected value of 0. I can assume that UJT has an expected value of 0. If it didn't, I could have changed the alpha. It would have been the same. Converges to 0 almost surely as, let's call it n, and approaches infinity. Or better way of stating that, as n grows without a bound. Now, this converging to 0 almost surely means the following. You can think of uncertainty as there are uncountably many different scenarios things could happen, right? And if something converges to 0, almost surely that means, except for a finite number of those possible scenarios, this thing is going to be 0. In layman's terms, as the number of terms in that portfolio gets larger and larger, the average is going to be closer and closer to 0, and the variance around that 0 is going to be smaller and smaller. So for practical purposes, U bar T will be 0 or extremely small. If n is large. Even with some oddly shaped possible populations, n being larger than 100 is good enough for law of large numbers to operate effectively. So that means this is not the expected value of the return, the actual return. R0t is alpha bar plus beta bar times nt. So the portfolio of that return of that portfolio, for all intents and purposes, depends only on systematic risk factors, and we're going to call that the market portfolio. Typically, market portfolio is portfolio of everything, not just stocks, bonds, and other stuff too. But in practice, we just use some sort of index. And such a portfolio is called a diversified portfolio. Anytime the return of the portfolio depends primarily on the systematic risk factors, that is the diversified portfolio. And this idiosyncratic risk factors do not play any role at all. Now, I'm not going to prove this in this class, but we kind of have a theorem. Any undiversified portfolio can be improved upon both in expected return and risk. That means undiversified portfolios are inefficient. So nobody's going to actually carry them in rational words. You're saying, but you are doing it. Well, I'm in the business of options and stuff, and I won't I'm kind of gambling, and I want to make quick money. So you can't think of me as a you can think of me as a rational player. Plus, given my beliefs, my portfolio is actually efficient because I believe that, for example, NVIDIA is going to keep growing like this at least for the next 2, 3 years. And given that kind of expected growth, even $3,000 is an underestimate of what its value. I may be wrong in that in terms of growth, but if that growth happens, this stock is going to be easily $5 trillion within 2, 3 years. It's only two now.